Hello, everyone, and welcome to the Musculoskeletal Functioning Lab. This lab is really fun once you get into your activities where you get to test yourself and or a participant and measure them and get to see where everyone kind of falls onto the CSEP standardized norms. But to get through this lab, you're going to need a little bit of information first, so let's get that to you. So, what we'll be covering is muscles, in particular, the different types of muscles, the names for their types of functioning, and how to go about analyzing their movement. So, in the field of kinesiology, that's called biomechanics. So, studying the angles and velocities of how your body is moving. We're going to do something a little bit more rudimentary in this lab, but it will definitely require you to get some assistance from your group, especially if you are new to human anatomy and human movement. The next part we'll go over is more to do with, again, how the muscles work themselves, in particular, how they work around joints in our body. So we'll look at flexibility. And the fun part about this, when you get into your activity, is you get to do a little bit of puzzle solving or detective work in figuring out what is or is not allowing a joint to be flexible. Okay. Then we get into the push-up tests, and we're going to go over some basics for that. And last but not least, also really fun, everyone really enjoys this part, is jumping power. So you'll actually be able to calculate and figure out how much power you can produce by trying a vertical jump. So there's different terms that people commonly use for muscle and muscle function. Primarily muscular strength, muscular endurance, and muscular power. Oftentimes, it seems like these terms are used interchangeably, and they really have their own unique and specific descriptions for each of the terms. So when we're talking about muscular strength, we're really concerned only with how much force a particular muscle or groups of muscles can produce in a single contraction. So in the weightlifting community, that's called a 1RM or a 1 rep max. So one repetition of an exercise at the maximum weight you can. And that indicates how much force that muscle or muscle groups are producing. And just as a little reminder that, again, force is a mass with an acceleration. Why is that kind of important to keep in mind? Well, it'll help differentiate from other terms a little bit farther down the line. But essentially, you're going to have some sort of a object with mass, and it's going to be moving. And in particular, when you're talking about muscles and limbs, it's your body that you're moving. Okay, and when you're talking about muscular strength, it's how much force that can move the object you're moving. So like a barbell with tons of weight loaded up on it. Okay. We'll move forward and it'll help clarify that a bit more. So muscular endurance is a little bit on the other end of the spectrum as strength, in the sense that it's more to do with multiple repetitions versus just one. So it still has to do with the amount of force that the muscle can produce, but how well can it produce it over multiple repetitions? And most commonly used in, say, like a weightlifting or personal training or strength and conditioning sort of context, you're generally speaking about a 10 repetition max. So you might think 10 reps isn't very much, and you're still speaking about strength, which you are, but the amount of time that it takes to do 10 repetitions of a particular exercise typically is enough that you get into the realm of endurance. So again, the biggest differentiating factor between strength and muscular endurance is one versus multiple repetitions. Okay. Last but not least, we'll touch on muscular power. So power is essentially whenever you do some sort of work over an amount of time. And work can look like a few different things. Typically, it's a force over a distance. So if I was to slide a box across a table, there would be work done on the box over a distance or two points in space, so displacement. If you take that amount of work, if you will, that had been done there, and again put that over time, so how long did it take for me to move that box across the table, that would be an indication of how much power it took. Okay, so to take something a little bit more applied to the human body and human movement, if you're talking about if you picture in the Olympics the clean and jerk, so that's and you've probably seen like weightlifting fail videos of this on the internet, but it's the one where the weightlifter or the athlete has a big barbell, all that weight on the ground, pops it up, puts it up over their head, and so you're having a large amount of weight from the floor overhead. So you have your distance, and the quickness that's done will help indicate how much power that athlete has as well. Okay, more specifically to when you are going to be doing your lab work to do with muscular power, that's going to be with your vertical jump. Okay. So if we take a little look at what's going on in the muscles themselves to produce each of those types of work, if you will, or types of use of muscle, so strength, endurance, power, again, it's all about force application. So the way that's done by the muscle is through different muscle fiber types. So one example would be if you look at the muscular endurance. So you're talking about slow twitch force. So the force is low, relatively speaking, but it's able to do it over multiple repetitions. Okay. On the other end, if you consider muscular strength, so maximum power output, maximum force, you need a certain muscle fiber that can produce a high amount of force, but you only need it for one repetition. So that's when you start looking at your type 2B, or what's more commonly referred to as fast twitch muscle fibers. For your purposes in this lab, we're not going to worry too much about type 2A or intermediate, largely because they are mainly trainable, which means that they can have characteristics of either slow twitch or fast twitch, depending on what sort of use that person has been training their body with. Next up, we're going to cover the terms that are used to describe how the muscles contract and move the body. So last we just spoke about how the fiber names, so the different fiber types within the muscle. And now these are going to explain how they move the body. Okay. So typically when you think of a muscle, most people think about the muscle contracting. So as the muscle shortens, that would move our limbs. But they also contract in a slightly different way, a couple of different ways. So the first one, again, is called concentric contraction. And again, that's the one that you would imagine the muscle getting shorter as the muscle fibers pull together, and then that would pull and leverage the limb. In this case, my bicep is contracting, the muscle is shortening and moving my forearm in a bicep curl. Okay. Eccentric contraction is any time that the muscle gets longer while also working against some sort of resistance. So if I held something really heavy in my hand, like a dumbbell, let's say, and I was slowly letting my arm move this way, is my bicep getting longer but still resisting against gravity. And so that's called an eccentric, as the muscle elongates, okay? So in both directions, it's my bicep. On the way up, it's my bicep. On the way down, it's my bicep, or with gravity. And again, when it's going with gravity, I'm not just letting the weight drop. It's not gravity totally taking over. I'm resisting that movement with my bicep as it gets long, okay? So there's a change in muscle length both for concentric and eccentric. Now, if I was to hold here at about like 90-ish degrees out to the side, I'll try to keep it in frame for you, but I'm just holding in one position. So my elbow here doesn't change position whatsoever, but it's a really heavy weight and I'm still holding it up against gravity. That's going to be called an isometric. So iso means no. So no moving, no metric contraction. So the muscle's just holding. Another really common exercise that you could probably picture in your mind would be a plank. So you don't move, but you're definitely working while doing a plank. And again, that's isometric. And all of these kind of come together to allow us to describe and, at a basic level, explain how movement works and how to analyze how the body moves. So you'll have a lab activity that you'll need to go through. Again, I highly suggest working through in partners or groups, and I definitely, if you can, try to find someone that might have done human anatomy in some way, shape, or form. That would be helpful. Otherwise, you can just do some research on your own. Use whatever resources you can. But I'll go through the first box or component of this to kind of help set you up for success here as we're going through. So we'll start with the squat. So when you're looking at the squat, you have your starting and finishing position here. And you can see in the box here, we want to start by looking at one specific joint. And then we're going to try to figure out what's going on with the body at this point, okay? So the up part and the down part of a squat. Okay, so again, we're going to try to figure out what joint that is. So in my mind, I'm already putting a little marker at the hip joint, okay? And you can feel on yourself, your hip. And I would definitely suggest doing some of these movements yourself to try to figure out and feel what's working, what muscles are contracting while I do these movements. It'll really make this activity all the more intuitive, okay? So again, you do your squat, you kind of feel out what's going on. And sure enough, as you're doing this, you kind of picture yourself, you're like, okay, well, I feel my quads, so the muscles at the front of my thighs, and my glutes working. Those are really the things working primarily. What joint is this asking? So it's asking for my hip. Okay, so what's the biggest main primary mover at the hip? Well, it's my glutes. So what I'm going to do here, I wonder if this will highlight the way I want it to. What I'm going to put in here, under the primary muscle movers, is I'm going to say glutes. Okay, they're the biggest primary muscles moving. Are there a bunch of other muscles in and around the hips working? Yes. If you want to, you can put them in, but again, just looking for the primary mover. So thinking back to what we just learned as far as eccentric and concentric movements, on the way up and the way down, if you think about it for a second, are different muscles working in either direction. So on the way up, my glutes contract in a concentric contraction. On the way up, what's lowering me through the exact same range of motion? It's my glutes. They're just doing an eccentric contraction. So down here, again, I'm going to put glutes, or glute max, for both, okay? Similar to that, now that I know what muscles are working, I can think about what sort of contractions they're doing. So here it says muscle or gravity, but you all know now, just from that last slide that we worked on, that the muscle contracting means concentric, and the muscle contracting with gravity, or getting longer against gravity as resistance, that's going to be called eccentric. So if I think of my glutes at my hip on the way up, as I come up out of a squat, I can think about the hip joint itself. The muscles to me, they're shortening. So the angle around my glute is getting smaller rather than larger as I stand up. Okay, hopefully I can find an illustration to put this in while I'm explaining it. If not, do the best you can to visualize this. Okay. On the way down, the angle of where my glute muscle is on the outside of my hip gets longer. Okay, so already I can think up, is contracting, getting shorter, concentric. On the way down, it's still holding me and resisting my body weight, but it's getting longer. The angle is getting bigger, the muscle is getting longer, eccentric, okay? So that's what we have here, okay? We can now, we can kind of go any direction, but this most easily relates to line of pull, okay? So parallel or perpendicular to gravity. So gravity is what's producing the resistance on whatever we have, the weight in our hands or the weight of our bodies. And so we know gravity is always pulling down, and it's a vertical line of pull when you're relating it to gravity. So we can look at what the resistance is in this example, and we know it's our body. So our body, if we're going up in a squat and down, what direction is that? That's up and down. So if you're going up and down in a squat, that is this direction, and gravity runs this way, so it's parallel. Okay, so we can say both on the way up and down, our line of pull is with gravity. And this makes sense, right? Last but not least, we got to return in our minds back to one of the first labs we did with actions of the body or limbs. Right? So if we, again, look at the hip and think of the hip exclusively, the action on the way up when you're going from this position up to this position is going to be one of two things, right? Either flexion or extension. So when you get to a full standing position, that's hip extension. So on the way up, I'm going to write extension. On the way down, it's doing the opposite, so that's flexion. Okay, and then that's completed here. I'm going to try to provide a little bit of an illustration to help you visualize some of what I just said with this. Yeah, I have it all prepped here. So this is the next one after completing the rest of that first activity. So something you can do with your mind's eye, and this is what you do in biomechanics, is you place little markers at each of the joints, so elbow, wrist, shoulder, hips, knees, and then you can draw lines to connect them all. And you can see here in the starting and finished position for the lateral shoulder raises, dumbbell shoulder raises, is we have two positions. Now, by just looking at the start and finish, something that you can instantly start to think in your head and ask yourself is, what's moving, what's staying still? Okay, so let's look at what's staying still. Here, the green box in the the start and the finish, exactly the same, no changes. Great, okay. So that stays the same. What did change? Well, we have our arm that started at a side position, moved laterally through abduction into this like T position. So what lines, what circle, red dot and lines moved there? Well, relative to the green line, you can see that this blue line, the arm, moved at this red dot, right at the shoulder. Okay, so that told me a lot. Okay, I know the shoulder joint is where the primary movement's occurring. I also know from this the arm didn't change position at all, really. At the elbow anyway, nothing changed there, it was all at the shoulder. And it also told me where that angle occurred. So now I know, okay, so it's a lateral movement. I know now that shoulder abduction. I know that the muscle group that works at the shoulder to lift up the entire arm is the deltoid. So that muscle there. And I can also see what angle got larger and smaller. Okay, so again, that's abduction to adduction. So abduction to adduction. and I can very clearly see where the joint angles are occurring. Okay. And so again, that should help you break down the movement, what muscles working, in what manner. To move even farther to the next step to fill out the rest of that chart, you can also think about this motion. Again, aside from just feeling it out yourself, like what's working here. You do abduction, it's a shoulder, right? So hold something heavy, like your textbook or something, if it's harder to figure out what it would be like lifting a weight there. So the other part is, again, line of pull. So we know gravity, again, on the body. This time, though, it's not your body weight that's generating the resistance, right? It's the dumbbells. So let's take a little look here. Sure. Why not? Okay. Hopefully that works. Okay. So your dumbbell here. Okay. And now we can think. We know this is the angle. We know that this, sure, it kind of curves. You know, the line of the weight or the dumbbell goes this way. So that might look confusing to you at first, but if gravity is always acting on the weight in this direction, you know, whether it's in this position or this position, the gravity is still working on it this way. And you're essentially, and again, this is where it helps to feel it out while you're actually doing it to help you think through this. But when the dumbbell is in this position, your shoulder's not working at all. You know, your hand might be working to hold the weight, but this is doing nothing. There is no work happening at that shoulder currently. When it's at this position, that's when it's maximally working. Okay, when it's out at 90 degrees, and you should be able to feel this. So when it's working there, where's the line of pull? Straight down. So you don't need to worry that it went on a curve or an arc here. You can say, okay, this right here is where the most work is. That's the most resistance, and therefore this is the biggest line of pull. So what is this relative to gravity? Perpendicular or parallel? Parallel. Okay. So again, I got lots of color and got a little messy there on you, but hopefully that clarifies it. And it just takes a little time, a little practice to start just seeing that without needing to draw on any lines and dots. If that helps you out, please do that. You know, that's definitely going to help you visualize it. Again, try it out yourself. That's going to help you get through that section. And certainly do this with partners. It's going to make researching and trying to figure out what body parts are moving. I mean, it's very reasonable to have something like this on a multiple choice question and ask you any part of the boxes that are presented to you in your lab activity for this. So it'll be good to be very familiar with and or see a new movement that isn't in your lab and being able to figure out any one of the questions that are asked of you in this lab. So again, this is definitely one of my favorite definitions of flexibility. And again, there's not something interesting is there's no definitive research stating being more or less flexible is better necessarily. So to a point, obviously having healthy range of motion within a given parameter is good. On the one end, if you're too restricted, you're prone to injury and certain health conditions and injuries. On the other end, if you're too flexible, again, there's a slightly different set of injuries and health issues that can occur there. So one interesting note is on performance. Typically in athletics, it's typically believed that having more flexibility is better. Although there was one study that followed a group of athletes that were doing 10Ks and training for a 10K race and found that at the end of this training program, those that had shorter hamstring length actually became faster. So again, it's a little counterintuitive, but you know, it's there's a bit of mixed results there, and obviously individual differences occur and vary. So as you go through your lab, you're going to have a few different aspects that you'll need to be familiar with as you're looking at flexibility. You're going to have one test that covers a lot of different muscles and a lot of different aspects of flexibility. So in particular, you're going to have multiple muscle groups that are involved in a particular movement. Your sit and reach. Okay. And it's used as a composite measure, so you can measure and look at a whole bunch of different muscle groups and their flexibility. But if there's restriction or limitations, it's good to be able to problem solve and again, kind of like a detective, figure out what muscles aren't allowing for full range of motion. Okay, so compound movement, just to go over some terms here, compound movement would be something where multiple joints are utilized in producing a movement. So the sit and reach is definitely one. You have your spine, which is already multiple joints. You have your hips, and there's a few others as well involved. So composition measure, again, that's what the sit and reach is. So you have multiple factors that play into this. Yes, you're going to be looking specifically at which muscle groups are limiting range of motion. However, a variety of things can play into effect, everything from various soft tissues or connective tissue, such as tendons or even ligaments that can have individual variation, but also something like your neurological state. So if you're slightly more stressed versus less, your flexibility is going to be different. So, and again, that has different states for an individual across time, but also differences between individuals and how much tone or stress, say, that somebody has. So ROM, you might see that notated in places. It stands for range of motion. It's kind of specific to whatever joint that you're referring to. And goniometer, that's this device. I don't know how easy that is to see, but essentially what it does is it will measure the degrees in range of motion. I'm going to have a little tutorial with this, but more or less you're going to put the centerpiece on the joint that you're trying to measure. You're going to anchor that to somewhere that isn't going to be moving, so fixed point in neutral. And then wherever the limb moves to, that's where you're going to use the numbers. Wow, you really can't see that as it's transparent. As we're going to check out the numbers on this part in degrees to indicate your range of motion. Okay, and that's great for looking at a single or individual joint. Okay, the next test that we're going to be doing for musculoskeletal function is a push-up test. It's kind of a classic strength endurance sort of test, and it can indicate a lot of different things, including core control and general kinesthetic awareness. So what does that mean? Essentially, when someone's holding a push-up position, and again, I'll draw proper form for you here in a second. You're gonna want to look at what their whole body is doing, their whole kinetic chain, their whole head to toe sort of position. So that's going to indicate how well they can hold their body, let alone the muscles that are working in a push-up test or a push-up, which is the pecs, the triceps, anterior delt a little bit, some serratus anterior for stabilizing, things like that. But it also indicates, again, that core control. Similarly, just watching people move, just observing how they execute a movement like a push-up can be an indication, especially if you're looking at a client, to see how much movement knowledge they have. So the brains, as you do sport and athletics, develop a certain awareness of your body in space. So kinesthetic awareness. And having a capacity or history of that can be demonstrated in a push-up. So if I rock on back here to the whiteboard, we're going to look generally at a push-up here. Some things you want to look for as you're doing either videoing your own push-ups for watching form, or again working in partners or groups. if you're doing it remotely, would be, again, if you kind of start in your typical push-up position, you really are looking for a straight line kind of head to toe. And I know that's not super realistic. This here, this triangle, that's your pelvis, okay? And we'll obviously make a nice circle for a head. There you go. So it's kind of a side view of your push-up. But again, you really are looking for this kind of being a straight line. Now, some things that people do, I should have switched colors there, but that's okay. As an error will be have their hips really, really high in the air and then feet down this way, okay? So their butts kind of stick up in the air. And what that's showing is not that the abs are working here, but the hip flexors, so the muscles that go across in front of the hips. And again, this can be an indication of core strength and core control, okay? Another alternative to that you might see as far as a breakdown in form, and this typically happens when people get tired, especially if you're trying to maximally push or do as many push-ups as you can, is typically some people's spines will kind of lag like this. So their low backs kind of drop down, maybe their butts kind of and their hips sag, and typically they kind of have, ooh, that was terrible, bent knees a little bit, not so they're touching the ground, but that, okay? And so this is really hard on someone's back. So if you ever see that, 2 repetitions, maybe maximum, try to help cue them up to fix it. If they can't, end the test, okay? I'll see if I can get some other illustrations to supplement this there. And then women, I get asked this a lot. Can I do push-ups from my toes? Do I have to do them from my knees? In order to compare to standardized norms, you do need to do your push-ups from your knees. So do that first, and then if you want, you can do the male push-up test from toes. But typically, I've come to find most women, once they do a max push-up test from their knees, they realize that was sufficient enough to score them adequately. So again, the only difference from knees would kind of look something like this. Actually very happy with that. Good. Okay, and again, hips will kind of be here. So notice here though, you still have this line from tip of the head to the shoulders, down the spine, to your hips, to your knees. Still a straight line, okay? Again, typically, if anything, as people are doing, women do their push-ups from this position, even men when they do it from this position, will typically, again, butt up, knees down, okay? And again, that's just the abs not working strong enough. Or sometimes people, if they're not confident in their tricep strength and upper body strength, they'll do this to try to make the position easier for them, okay? So something to watch out for during your push-up test. All right, last but certainly not least, we have the vertical jump. This one's great, straightforward, pretty simple as far as executing the test. But you're really looking for a single rep over time. So you're looking for, again, power, force over time, or work over time. That's an indication of power. You'll be able to do some calculations. And the unique part about this isn't even so much calculating power, but is when you look at the eccentric utilization ratio. Okay, lots of big words there, but you know these, you know this. So eccentric, what was that? We just covered that at the start of this lecture, right? So that's when muscles get long, right, under a load or resistance. So there's 2 ways you'll do a jump. And typically, if you're a skilled jumper, you already do this naturally. You utilize a counter movement jump. And again, I'll try to find some demo videos and stuff for you here, either here or supplement. But you kind of use this little bounce. That little bounce uses a few different properties. It's either the nervous system, the elastic property of muscle, and trying to figure out what that stretch shorten mechanical reflex, how much of that you use can be done. You can figure out how much you use looking at the eccentric utilization ratio. So what is the difference between your counter movement jump, the jump you use with the bounce, with that stretch shorten cycle involved, and one where you don't have that involved, so a non-counter movement jump. So essentially you get to the bottom of your jump, you load up, and without a bounce, and this is actually very hard, so be very careful. You're purely jumping up, there's no bounce. What is the difference between those jump heights? And it'll tell you how much you're using that eccentric or that bounce bonus for when you do your jumps. So we're going to pull it all together here. What have we learned so far in this lab, and how are we going to apply this? Well, muscles, you learned they contract differently depending on the movement they're producing. You learned that they can do different types of work, so defined as strength, endurance, and power. You have your eccentric, concentric, and isometric contractions, and those all work in slightly different ways to produce the movement. And you know that through your movement analysis now. You can look at a joint, look at muscles, look at the body and the limbs and how they're moving, and using your descriptive terms from the earlier labs as far as flexion, extension, abduction, you can combine that now with your eccentric and concentric contraction terminology and really get a strong capacity to explain how the body is using its muscular system for movement. And part of that has to do with the flexibility around the joint spaces. So with today's lab, you really, by going through it, you're going to get a very good understanding of how to look at movement, describe it, and again, through your flexibility aspect, kind of discern, and problem solve where some maybe muscular issues are cropping up. So for example, restricted movements. So I hope you enjoy the activities you do for this lab. It's a little challenging if you haven't had exposure to human anatomy as far as taking a course in it or biodynamics or other movement classes, but I'm sure, again, it's a pretty fun one, trying to figure it out and work through it with some of your peers. So enjoy the lab activities, and I look forward to hearing from you and your discussions on this.